Welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, unit 4 chemical bonding and molecular structure, and in this video we will discuss about Valency bond theory, that is VBT. It was introduced by Hitler and London in 1927 and developed further by Pauling and others. It is based on the knowledge of atomic orbitals, electronic configurations of elements, the overlap criteria of atomic orbitals, the hybridization of atomic orbitals, and the principles of variation and superposition. About atomic orbitals, we have already discussed. Electronic configurations of elements, we already discussed. And in this chapter, we will discuss about the overlap criteria of atomic orbitals and hybridization of atomic orbitals. And this principles of variation and superposition is out of our syllabus. Okay, and we will only discuss the qualitative approach of overlap criteria and hybridization, no mathematical calculation. Okay. According to this theory, a covalent bond is formed by overlapping of atomic orbitals. Before overlapping, atomic orbitals undergo hybridization. A bond is formed when attractive interactions balance the repulsive interactions and net energy is lowered. Consider the formation of hydrogen molecule, that is H2. It is formed by two hydrogen atoms. Consider two hydrogen atoms A and B approaching each other, having nuclei Na and Nb, and electrons present in them are represented by Ea and Eb. Okay. Now, attractive forces arise between nucleus of one atom and its own electron, that is NaEa attraction. Okay, this is the nucleus of atom A and this is the electron of atom A. Attraction force is already existing. In the same way, this is the nucleus of atom B and electron of atom B. When they approach to each other, some new attractive forces arise, and these are nucleus of one atom and electron of other atom. That is this NaEb and NbEa. This is the nucleus of atom A and electron of atom B. And this is the nucleus of atom B and electron of atom A. These are the new attractive forces. At the same time, when they approach to each other, some repulsive forces also arises. And these repulsive forces arise between electrons of two atoms like Ea, Eb, that is electron of atom A, electron of atom B, and nuclei of two atoms, that is nucleus of atom A Na and nucleus of atom B Nb. Because these electrons have same charge, they repel to each other. These nucleus also have the same charge, they repel to each other. Now, attractive forces tend to bring the two atoms close to each other, whereas repulsive forces tend to push them apart. Okay, and in this diagram, forces of attraction and repulsion during the formation of H2 molecule are shown. Okay, this is during the. Now, in this diagram, attractive forces are there. The dashed line represent the old forces and solid line represent the new forces. You can say this attractive force is already between nucleus of A and electron of A, and this attractive force is already existing, nucleus of atom B and electron of atom B. But when they come close, these are the new forces, nucleus of atom B and electron of atom A, and nucleus of atom A and electron of atom B. Okay. Now, repulsive forces. This repulsive force is between electron and nucleus. This is electron of A and electron of B, repulsive force. And due to this repulsive forces, they tend to push them apart. That's why this arrow mark indicated like this one. Okay. They are going apart. And this repulsive force between nucleus of A and nucleus of B, again they repel to each other. Okay. Magnitude of a new attractive force is more than the new repulsive forces. As a result, two atoms approach each other and potential energy decreases. Ultimately, a stage is reached where the net force of attraction balances the force of repulsion and system acquires minimum energy. At this stage, two hydrogen atoms are said to be bonded together to form a stable molecule having the bond length of 74 picometer. Since the energy gets released when the bond is formed between two hydrogen atoms, the hydrogen molecule is more stable than that of isolated hydrogen atoms. The energy so released is called as bond enthalpy. Okay. Now, same thing can be represented by this diagram. This is called potential energy diagram for the formation of H2 molecule. Now, see, at this condition, when there is no attraction between these two atoms, okay, energy is considered as zero. When they approach to each other, okay, when this distance is a decrease, they are approaching to each other, the attraction force is increases and energy is lowered. Okay, energy is lowered. And one situation is there when attraction and repulsion balance to each other, and at this condition the energy is minimum. Okay, and this energy, that is from this to this is known as bond enthalpy, and in case of hydrogen this is minus 436 kilojoule per mole. Suppose if they try to come more close, then what will happen? Then repulsion force will increase and again molecule will be unstable and bond will break. Okay, and this equilibrium distance, this one, when attraction balance the repulsion, this distance is internuclear distance, or this is bond length. Okay, and this is 0.74 angstrom. In terms of picometer, this is 74 picometer. Now again we compare three situations. When H's distance is 74 picometer, the repulsion balance the attraction, strongest bond is formed, optimal overlap is there, lowest energy is there, and bond enthalpy is minus 436.8 kilojoule per mole, and you can also write approximately 436 kilojoule per mole. Okay, now this is the overlapping, optimal overlap. What is this overlapping of atomic orbitals? This we will discuss in the next video. Okay, now if the H's distance is greater than 74 picometer, it means this situation is there, greater than. Then what will happen? That is again attraction is greater than repulsion, but bond is weaker because overlap is not optimum. Too little overlap. That's why atoms come closer. Okay, this is small overlapping. Attraction is there, but overlapping is not optimum. Now, if we assume third situation, when H's distance is smaller than 74 picometer, then what will happen? Repulsion forces are greater than attraction, weaker bond is there, and in this case overlap is too very large overlapping. That's why atoms get further apart and bond will not formed. This is the situation. When large overlapping, repulsion is there. This is all about valency bond theory. Thank you. Subscribe my channel to get the next video. In the next video, we will discuss about the overlapping of atomic orbitals.